Hello, welcome to 13 Universal. Um, Learning Beyond Barriers. This is CIE A level Plant Transport Series 3. So, this is Schedule your tutor. Don't forget that your exams are coming next week, 11th. So, bring your writing materials. Let's look at plant transport. Is that okay? So, let's go, guys. Um, the first question here says which features of companion cells are essential to their function? Which features are essential to their function? Let's look at that. Okay, the first one says, okay, these. Okay, so pause the video and try to solve the question. Pause the video. The first one says they are connected to sieve tube elements by plasmodious matter. So we're looking at companion cells. Is that okay? So companion cells, we're looking at the essential features that are essential for their function. So the first one said that they are connected to the sieve tube element by plasmodious matter. Yes, the function of companion cell is that they help in the loading of sucrose. So once they load sucrose from the source cell into them, all right, now from the companion cell, now sucrose can move. Okay, I look at it. I'm just trying to show you a diagram that looks like that. Okay, now just to show you, give you a clue. Right, now let's assume that this is companion cell. This is companion cell. Is that okay? I'm drawing it, of course. That's source cell, source cell, source cell. So companion cell is usually between the source cell and the sieve tube element. The sieve tube element, I didn't draw it very well, but sieve tube element is always joined to others, all right, and they form a tube. Not quite well drawn, but just trying to paint a picture. Is that okay? So you usually have sieve plates, right, through which sucrose or assimilate can pass down. Okay, so you can see here, guys, very key, the major role of companion cell is to load sucrose. This is companion cell, the one in the middle. This is source cell. So once sucrose moves in here, sucrose moves from the companion cell into the sieve cell. Okay, sieve tube element through this is plasmodious matter. This is it. Okay, so number one is correct. Number two says they have a thicker cell wall than a sieve tube element. So we're looking at something that is essential. The cell wall, thickness of cell wall is not essential for their function. Okay, so number two says they contain nucleus and mitochondria. Yes, so they contain nucleus. So somebody should ask why. Why do they contain nucleus? Right, they contain nucleus because they need to make protein, transport protein. They need to make transport protein. They need to make transport protein like hydrogen ion pump, which pumps hydrogen ion from cytoplasm to the cell wall. Okay, and to make protein, you need transcription. Transcription occurs in the nucleus. So they need mitochondria, right, to power it. All right, so to power protein transport by active transport. Sorry, hydrogen ion transport. Is that okay? Because usually hydrogen ions or protons are pumped into the cell wall. Is that okay? By the companion cell, and that requires a protein here. That protein is made. Nucleus is involved in that. The movement of proton into the cell wall is by active transport, so it requires energy. So that is why we need mitochondria. Provides the energy to pump proton against concentration gradient from the cytoplasm of companion cell to the cell wall. You see the cell wall here. So both of them are needed. So you see that number one and number three are needed, okay, for its function. All right, so the answer is 1 and 3. That's okay. So let's go to the next question quickly. Which statements about water movement in plants are correct? Which which statements about water movements are correct. You can see that. Yeah, pause the video and try it. Okay, so pause the video and try it, guys. It says water can pass through cellulose cell wall. Yeah, water can pass through cellulose cell wall because cellulose, okay, is polar. You know cellulose is polar, guys, because cellulose has hydroxy group, so it is polar, so it can form adhesion, hydrogen bonds with water. So this is the reason. So number one statement is correct. 2 says water can pass through lignified cell wall. Now water, lignin is waterproof. Lignin, so lignified cell wall is waterproof. One of the reasons why cell walls are lignified is to ensure that water does not leak out of xylem walls. Okay, so water cannot pass through. Water can pass along the wall. Okay, this is xylem wall. Okay, now I'm showing you something. That is xylem wall. Right, sorry for the diagram. So xylem wall. So you see water column forming by cohesion. Water molecules form water column, but they also form adhesion. Okay, so water can pass along the wall of xylem because they form hydrogen bond with lignin, hydrophilic part of the lignin, but they cannot pass across it. Water can live, right, except through peats, you know, the places that have less lignin. Okay, so peats allow water transport, okay, laterally. So but water cannot pass through, but they can move along it. So that is why 2 is wrong. 3 says water can pass through cell walls that contain suberin. Okay, suberin is non-polar, so it contains it contains waxy cortical. Is that okay? And waxy cortical is hydrophobic, so water cannot pass through. That is why water is not transported by what we call apoplast through the endodermis, because endodermis have suberin. So 3 is not there. But if you look at the option, right, so we don't have only 1 there, so you call back, you look at these 2. Water cannot pass through lignified cell wall. They say water can pass through cell walls that contain suberin. This you know is outrightly out of it. Okay, but water cannot pass through lignified cell wall. Yeah, but it can pass along it. All right, so we can choose 1 and 2 because that's the only suitable option we have here. Okay, 3 shouldn't be there because water cannot pass through the cell wall. Okay, so 1 and 2 is the most suitable option here. All right, let's look at the next question. The next question here says that the diameter of a tree trunk usually decreases slightly during the day. Okay, changes in environmental factors during the day could cause the diameter to decrease, right? So which changes in environmental factors during the day could cause the diameter to decrease, right? And look at it here. So remember that the diameter of the tree decreases, guys. The diameter decreases because of transpiration pool. Transpiration pool is a suction force, guys. It's a suction force, just like the same way when you use your straw to drink. Now this is xylem. When you use your straw to drink, all right, when you mount pressure, you try to suck your drink using the straw, your orange drink. Have you noticed that when you try to suck it, the wall of the straw tries to collapse? So transpiration pool is acting here. This is the top of xylem in the leaf. So once there's increase in the rate of transpiration, all right, it will cause the wall here to reduce. The wall of xylem here, they will reduce in size. Okay, so you see that the size of xylem, the diameter of xylem, right, that diameter, it depends on transpiration pool. So it's inversely proportional to rate of transpiration. Please don't forget, this question is always coming out. So that means the higher the rate of transpiration, okay, the wider the diameter. Sorry, the smaller the diameter. Okay, why the smaller the rate of transpiration, the wider on the diameter. So if we're having a decrease in the trunk, that means that transpiration pool is high. So the question is, which of these factors increases rate of transpiration? Right? So remember that humidity, you see this humidity is inversely proportional to rate of transpiration. Rate of transpiration. Is that okay? And remember that temperature is also directly proportional to rate of transpiration. Don't forget that. That means as temperature increases, rate of transpiration will increase because of increase in evaporation. Kinetic energy of water molecules increases, and then we have more water evaporating, setting up steeper concentration, water concentration gradient. So you see, wind speed is also directly proportional to rate of transpiration, guys. All right. So what we are looking for is which of these factors causes high transpiration, because high transpiration causes decrease in the diameter, right, of the trunk of trees. So the ones that can cause increase in rate of transpiration, you can see that is wind speed. Increased wind speed causes increase in rate of transpiration, right? Increased temperature causes increase in rate of increased temperature causes increase in the rate of transpiration. So if you increase humidity, rate of transpiration will decrease because there's inverse relationship. All right, so it's only increase here and increase here that can cause increase in rate of transpiration, which decreases the diameter of the trunk of trees. So this is our answer, guys. Okay, let's go. Come on, let's do this. Number 4, which sequence of events could lead to mass flow in a phlegm sieve tube? Mass flow. Yeah, so I'd like you to pause the video. And so which sequence of events? I tried to explain it the other time. Let me explain it quickly the other time. So which sequence of events that would lead to mass flow? Remember that this is the phlegm. Is that okay? So this sieve plate, of course I'm trying to the end wall here, sieve plate. Is that okay? And this is phlegm sieve tube element, showing you the sieve plate. You can see the sieve plate there. You can see the sieve plate, guys. All right, but meanwhile, try to solve the question. So this is the companion cell. Is that okay? Yeah, companion cell helps in the loading of sucrose. Right? Yeah, that's companion cell. It helps in the loading of sucrose. So let me show you something here. Okay, it helps in the loading of sucrose. Yeah. So I'm just trying to explain this. So we have something like this. Okay, we have something like this companion cell. Yeah, just to draw the diagram for you. Okay, yeah, you can see that that's companion cell. Yeah, cell wall, you can see that. Yeah, so this is a source cell. Okay, so the first thing that happens is that sucrose is loaded. So how is sucrose loaded? So hydrogen ion is first of all pumped into cell wall. Okay, so you see hydrogen ion here. Can you see hydrogen ion? Yeah, actively pumped into the cell wall to set up hydrogen ion concentration gradient. So hydrogen ion concentration gradient is set up in the cell wall of companion cell. Did you get? Yeah, and that is done by hydrogen ion pump, a transport protein here. Okay, in the cell membrane. Okay, so that's the first thing that happens. Let's go there. Which one says that? So number 5. Number 5 is the first thing that happens. Okay. Now, okay, this is how sucrose is loaded. First of all, protons or hydrogen ion are actually pumped out of companion cell from companion cell here into the cell wall, and that sets up hydrogen ion concentration gradient. The hydrogen ions will now move in back by facilitated diffusion, but together with sucrose. So they are going to move in back. Okay, sucrose move with hydrogen ion All right, sucrose is moving against concentration gradient. Hydrogen ion is moving down concentration gradient, but they are moving, all right, through a co-transporter. So let's check here which one shows a co-transporter. Okay, a co-transporter. So proton and sucrose moves into components through a co-transporter. This is the second event that happens, right? Do you get? And the third event is that once they move here, sucrose will now diffuse through the plasmodesmate matter into the sieve tube element. So sucrose diffuses. So what is the next one? Sucrose moves into the sieve tube element. You see? Sucrose moves into sieve tube element. This is the third event that happens here. Okay? That's the third event. And when sucrose enters here, it sets up high water potential. Sorry, it lowers water potential gradient here. When it lowers it, because it's a solute, so water is going to move in by osmosis, and that increases water potential gradient. Right? And then because we have more water moving in, remember sucrose moves in, lowers the water potential, then water moves from neighboring cells, right, by osmosis, and that increases the volume of assimilate here, right? And because we have more volume, and that causes increase in hydrostatic pressure. Do you get? But meanwhile, once sucrose moves in, it's going to, the water potential sieve tube decreases. This is the fourth thing that happens. Okay? And then what happens is that water is going to move down, all right? This is the 15, and when it moves in, the 16 that happens is that water potential, hydrostatic pressure increases. So if you check, the first one there is number 5. See, number 5, followed by number 2. Okay? So you see, this is sequence. Please don't forget it. All right, the question, that's answer is D. The table shows the observations made by a student about 3 different cell types, P, Q, and R. Okay, transverse section of a plant tree using a light microscope. Let's see. So this is it. Like you to pause the video. It says, what type of cells are P, Q, and R? So pause the video and tell us what you got. Okay, don't forget that, you know, we have P here. P is, the thickness is not much, but it has no, it's a structures observed, right, in cell content, none. So out of these companion cell, phloem C2, xylem vessel, which one does not have any cellular component? Of course, companion cell has cellular component. Okay, do you get? Yeah, but xylem vessel element do not have. So we are focusing on C and D. Let's roll it. So Q says 1:20, the thickness is increasing, but regular pattern of circles in some cells. Regular pattern of circles in some cells. That's this showing thin cytoplasm, and that thin cytoplasm is by phloem C2. When we have granular appearance of cell, that is companion cell, because it has thick cytoplasm, thick, and also it has more organelles. Okay, it becomes granular. So the answer is therefore delta. Let's move speedily. Water molecules are attracted to each other. This property is important in the upward movement of water in the xylem. So which term is used to describe the attraction of water molecules to each other? Okay, so I want you to pause the video. So when water molecules are attracted to each other, what term do we use for that? What is used for that? What term do we use for that? Okay, so water molecules are attracting to each other. So what term? This is a water molecule. Okay, what term do we use for that attraction? This is negatively, okay, partially negatively charged. Let me clean it, because it is more electrophilic. High oxygen. This is oxygen. You understand, guys? I'm just trying to explain to remind you how this works. So this is partially positively charged. So oxygen draws the shared pair of electron towards itself. Okay, hydrogen, all right, is less negative. So that's why it's more positively charged, but partially. So you see another water molecule. That's oxygen of this water molecule. That's the first hydrogen, all right, of that water molecule. That's the second hydrogen, guys. I'm just trying to show you how this works. You guys remember? So this is negatively, partial negative charge. So there's going to be attraction between this and this. That's hydrogen bond is formed here, and this attraction is called cohesion. So water molecules stick to each other. But if it is with another molecule, it's called adhesion. Is that okay? All right. So the answer is cohesion. The diagram shows a model to demonstrate mass flow. Okay, that's mass flow here. I'd like you to pause. So in a plant, what are the structures W, X, Y, Y, and Z, and what is the direction of flow of solution along W? Okay, pause the video and try it. Okay, pause it. Don't forget that we have concentration. Concentrated sucrose is concentrated here, so this is the source. That's the part where we have high concentration of sucrose. It's coming from there, so this is going to be our source, and source is from the leaf. So where is leaf here? Which leaf should be Y? So our answer is either B or D. We have eliminated A and C because the leaf is a source. Okay, now this is where it is being taken to. So this is going to be root, which is the sink. Z is a sink, guys. So that's root. So which of them, B and C, has, okay, two of them have Z as the root sink. Okay, let's follow them. Now sucrose is going to be transported from Y to Z. Okay, right, so which of them is from Y to Z? Oh, Y to Z. See, B is the answer, right? Because D is saying from Z to Y. It's going to move from high concentration to low. And if you check here now, X should be, this is water. They already told us that this is water. So water is moving through xylem. So xylem is X. You can see that. All right. Yeah. So phloem is W, because it carries sucrose. So B is the answer, guys. All right. Let's run. Which properties of water molecules are important in the upward flow of water through the xylem? Is it xylem? Phloem. So which one is important? Now try this question. These questions are cheap. Pause the video and try it. Water molecules are attracted to each other. Yes, by hydrogen bonds. So yeah, they're attracted to each other. So if this is xylem, right? So this is water at the root. You see, water molecules, they are attracted to each other. You can see that. Okay, so they stick to each other. They form column of water. You can see that. They're attracted to each other. Attracted to each other. Attracted to each other. You can see that, right? So that's cohesion. So water molecules are attracted to each other by hydrogen bond. That this is correct. Water molecules number 2 are attracted to cellulose by adhesion. So you see, cellulose is on the wall of xylem. This is the wall of xylem, all right? So they actually, all right, are attracted to cellulose by adhesion. Yeah, this is also correct. Water columns have high cohesion. Water molecules have high cohesion in water columns. Yes, so that helps it to pull out. You can see that because water molecules stick to each other, that forms water column, and then water can pull each other upward during transpiration. All right, transpiration pulls the water column because water molecules stick to each other. So I think 3 of them are correct. Okay, so let's go to the next question, guys. Yeah, let's go. It said the graph shows the rate of water absorption and the rate of water loss by a plant during 124-hour period. The plant was growing in natural conditions. You can see that. Okay, what may be concluded from the graph? So what do you think is the answer? Okay, this is an analysis question. You can see the thick line is for absorption, the dotted line is for water loss, water absorption. It's day, night, night. Rate of absorption. Okay, let's go. What may be concluded from the graph? Let's practice critical thinking. Okay, now the first question says the rate of water absorption and the rate of water loss peak at 1600 hours. This is 1600 hours. Okay, yeah, is this correct? Okay, if we trace it, you can see it actually peaks. Yeah, both of them peak. Yeah, both the thick line and dotted line absorption, and yeah, the peak there, the highest is here, which is yeah. So this is correct. We'll take it. The rate of water loss is greater than the rate of water absorption for 12 hours. The rate of water loss, this is water loss, is greater. Starting from here, this is 8 p.m. So it's greater from here to this point. Okay, this is also 8. I think it's 8 a.m. and 8 p.m. Okay, so the gap between here and here is 12 hours. Yeah, so that's correct. The rate of water absorption is greater than the rate of water loss at night. Absorption is greater than absorption. This is night season. Okay, so absorption is greater. Night season here, absorption is greater. So yeah, so 3 of them are correct. Yeah, let's go to the next question, guys. Which statement explains why a stem is caught underwater and connected to a porometer? Okay, underwater. Yeah. So which statement explains that? Pause the video and try it. Pause it. To prevent plasmolysis of xylem versus element. Well, xylem is already dead cells, okay, or hollow. Okay, it's not to prevent plasmolysis. Plasmolysis is due to low water potential. Is that okay? But that's not the reason. To prevent the collapse of xylem. Yes, to prevent the collapse of xylem vessel elements. So xylem vessel elements do not collapse because of that, because they have lignin. They have lignified wall. Number 3 says to prevent air entering xylem. Yes, to prevent it, because the air that enters the xylem will break the water column. So there's what is called continuous water column. Water molecules stick to each other. They form a column. So when air enters, where we break the continuous column of water, and that affects the movement of water column upward. So 3 alone is the answer. All right, let's go to the next question. Sucrose moves into an actively dividing shoot. So this is shoot tip from a phlegm sieve tube element, which changes to the water potential and the volume of liquid, and the phlegm sieve tube element, are correct. Yeah. So which one is the answer? Pause the video and try it, guys. So pause the video. So let's assume that this is phlegm. This is phlegm tube. Okay. The phlegm tube. All right. You can see the phlegm tube here. Yeah. And of course, the phlegm tube is made up of what we call phlegm sieve tube. Phlegm sieve tube. Phlegm sieve tube. Okay, which has end walls. You can see. So it's it's just like that. So let's get to what we need. This is what we need. Okay. So you can see that now. You can see that this is the companion cell, and of course and that is okay. Let me clean it. Yeah, sorry about that. Now look at this. Okay, that's companion cell. I'm just sketching this, and this is zinc. Zinc is a shoot tip. Is that okay? So sucrose is going to be moved from here to here, right? Don't forget that sucrose is moved from, this is the phlegm sieve tube. Okay, so it's going to be moved to the shoot tip through a companion cell. Is that okay? So when you move phlegm from here to here, when you move sucrose, this is sucrose is going to be moved by diffusion. Sucrose is moved, and from here, once it enters the shoot tip, it is broken down by an enzyme called invertase. So when you move the sucrose, what happens is water potential increases because you remove a solute. So water potential quickly increases, and then water would now move out, out of the phlegm sieve tube by osmosis, to neighboring cells or into the sink with sucrose. Okay, so immediately you remove it, water potential increases. So water potential increases, that means water becomes less negative. That's high water potential means less negative. When you move sucrose out, the amount of solute decreases. So the amount of solvent will increase. So that means water potential increases, and the increase in water potential is said to be less negative. So that means that C and D are eliminated. Okay, so we are working on A and B, guys. So, but you see, once you move out sucrose, water potential increases, then water is going to move out, all right, into neighboring cells. And when water moves out, the volume of the liquid here decreases because water is moving out. And that's actually what sets up low hydrostatic pressure here. So the answer is A. Okay? All right. So, yeah, sucrose is loaded into phlegm sieve tube from companion cells. What is the correct order of order of statement that explains this mechanism, guys? So we have done this before. I expect you to do that. Okay? So we've done this before. Okay? We've done it. Pause the video and solve it. Pause it and solve it. Pause it and solve it. Okay? So don't forget, first of all, sucrose is moved, pumped, not sucrose, hydrogen ions pumped into the cell wall. That's what's happening. Okay? So start with number 2. This is number 2. Okay? So the only option that starts with number 2 is C. That's okay? And you see that hydrogen is going to come back through co-transporter back to this companion cell. So that is why number 1, hydrogen ion diffuses into that's so the answer is C. All right. So let's go on. Which description of the adaptations of xylem vessel element to their function are correct? So what is correct about the adaptations? Okay. So I want you to pause the video and answer this question. Okay, pause it. The first one says that they have pits between vessels, allowing water to pass from one vessel to another. Yeah, they have pits. Pit is only in part, and also pits help in lateral transport of water. Pits help to remove airlocks. Okay, so 1 is correct. 2 says they are taken with lignin to stop them from collapsing. Yes, lignin provides mechanical support. 3 says they form a continuous hollow tube through the plant, providing little resistance. Yes, so all of them are correct. Okay. The diameter of a trunk tree usually decreases slightly. We have solved this question during the day. See, they repeat this question a lot. All right. So which changes in environmental factor during the day could cause diameter to decrease even more? So remember that what is causing decrease is increase in rate of transpiration. Guys, I don't expect you to waste time to kill this. If you have been following me in this video, solve this question right away. Remember that the trunk of trees decreases because there is high, all right, rate of transpiration. Okay, so which of these factors here causes increase in transpiration? Which of them? This is increase. Now increase humidity is inversely proportional to it, right? So humidity cannot increase in humidity will not cause increase in rate of transpiration, but increase in light intensity, right? Yes, because it's directly proportional to it, will cause, right, increase in rate of transpiration. The same thing with increase in wind speed. So the answer is always there. So it's between increase in wind speed and light intensity, which is B. Okay, let's go on, guys. No time. A student wanted to find out the rate of transpiration using a porometer as shown. Okay, see a porometer. Yeah, isn't it cute, guys? The student was told to work out a value for transpiration using the unit. So the unit means that it's gonna get the volume. It's gonna get the length, get the volume divided by length, that's divided by time. So it's gonna get all these values. Okay, which measurements would the student need to take? Pause the video, guys. Which measurement does it need to take? So this guy needs to get the volume. Okay, so volume of a cylinder, that this is volume of water, estimated volume of water here. and this is a tube, this is cylindrical. So volume of a cylinder is remember the formula, guys. It's going to be pi r squared height. So this height is the distance moved. So we need to get the radius, get the distance moved, which is represented by height here. Okay, so we need to get the time. So which one? A says volume of water in the reservoir, length of the capillary tubing. No, we don't need that. We need to know the distance moved by the air bubble, not the length. Okay, all right, we need to measure the distance. So and then use it to calculate the volume. B says volume of water in the reservoir. No, we don't need volume of water in the reservoir, though we need radius of the capillary. We don't need it. All right, yes. C says distance air bubbles moves. Okay, this is correct. Radius, yes, need capillary, and time, yes, we need time, and then surface area of the leaves. Yeah, we need them. We don't need temperature. All right, so you see, this shows us temperature, don't need it. So the answer is Charlie. So let's go to the next question, guys. All right, as in plants, assimilates such as sucrose are loaded from source. Yeah, they're loaded from source cells into the sieve tube element, guys. The assimilates are then transported from source to sink. So this question keeps coming out. What is needed to transport sucrose from source cells through phloem tissue to sink cell? What is needed? What is needed? Water potential gradient between source and sink. Is that what is needed? Pause the video and try it. Do we need water potential to move sucrose? Okay, because we don't need water potential. Do we need ATP? Yes, ATP during loading. During loading of sucrose, don't forget that during loading of sucrose, that hydrogen ion is actively pumped into the cell wall of companion cell. Okay, and that requires ATP. Remember also we need hydrostatic pressure gradient because sucrose moves from the source here to sink. This is phloem tube element at the source, this phloem tube element at the sink. It moves by down hydrostatic pressure gradient. So this usually have high hydrostatic pressure, this has low hydrostatic pressure. Okay, so we need two of them. Okay, so when sucrose moves from companion cell into this one, you know what happens? It lowers the water potential so that water moves in. So once water moves in, the volume of assimilate increases, and that causes high hydrostatic pressure. Then when sucrose is moved out of the phloem sieve tube at the sink, so water also moves out with it. So the volume decreases. So we have low hydrostatic pressure gradient. That sets up hydrostatic pressure gradient, which causes sucrose to move from phloem sieve tube at the source to the phloem sieve tube at the sink by mass flow down hydrostatic pressure. So C is the answer, guys. So let's run. Some of the features present in transport tissues are listed. You can see that. Yeah. Okay. Which features are present in xylem vessel element? So which ones are present? So guys, which ones are present? Pause the video and try it. Xylem vessel element, that's what we're asking. Look at which ones are present. Yeah, xylem have lignified wall. The lignin makes it waterproof so that water doesn't leak out, and it gives it mechanical strength. Xylem does not have cytoplasm to reduce resistance to flow. Xylem doesn't have any organelles. Yeah, it has pits, doesn't have plasmodious matter. So you have only 1 and 4, guys. The diagram shows transverse sections through parts of plants. Yeah, okay. Which role is correct? Yeah, which role is correct? I'm asking you. So pause the video. So which role is correct, guys? So don't forget, guys, which role is correct? That this is a leaf. This is upper epidermis, that's lower. So the first, these are vascular bundles. The first you see is xylem. So one is xylem. Okay. Now this is a stem. Okay. You can see how the vascular bundles are arranged. Almost round, circular. Okay. The one inside is xylem. Xylem is 4. So 1, 4. So this is the root. Xylem is at the center. So 146 is xylem. And xylem contains lignin. Which one has 146? Oh, that's it. See? Yeah, so the other one said transport organic solid. So this contains lignin, xylem. This is phlegm. Phlegm should be 2, right? 3, 5. So the answer is B, guys. Which molecules form hydrogen hydrogen bond, okay, with water during transpiration? Okay, with water. Cellulose in the xylem wall, is it correct? Okay, which one? Pause the video and try it. Pause the video, guys. Cellulose in the xylem wall, yes. Suberin, no. Okay. Other water molecules, yes. So this is adhesion, this is cohesion. Cohesion, adhesion. Is that okay? So it's 1 and 3. Alright. Some plant species can take up heavy metals, contaminants, that are dissolved in soil, water, and then transport them within the plant. Within plant cells, the heavy metals accumulate mainly in the vacuole. They accumulate in the vacuole. Which suggestions about the transport and accumulation of heavy metals are valid? So guys, this is the fish fried. This is the kettle of fish fried so that we can eat. I'm hungry, guys. So solve this question. That's what I meant. Now look at this. Which suggestions about the transport and accumulation of heavy metals are valid? Okay, look at the first one. After initial entry into the root, some of the heavy metals can pass through the tonoplast. The tonoplast is a membrane of vacuole. Heavy metals, okay, can pass through to be stored in the vacuole of cells in the cortex. Yeah, vacuoles can store, they can store ions. So this is valid. They can be stored there. Let's check the second one. The heavy metals take an apoplastic pathway in the xylem, but at the endodermis they must take symplastic pathway. Yes, apoplastic is movement from cell wall to cell wall, okay, and even intracellular space, cell wall to cell wall. Now when they get to endodermis, because endodermis have suberin, so they cannot move through the cell wall. Suberin prevents the movement of charged molecules of water, so they follow symplastic. Symplastic is through the plasmodious matter, right? So this is also valid, guys. 3 says the rate of accumulation of heavy metals in leaf cells will be faster at night. Okay, at night there will be no light, so there's no effect of light intensity on the rate of transpiration. Okay, transpiration pulls water upward. Do you get? So night will give us basically low transpiration because of the absence of light intensity. Okay, so this is not valid. 4 says the presence of heavy metals causes the transpiration streams to slow. This is slow down. Slow. This is typo. Slow down and reduce the rate of transpiration. No, heavy metals does not have any effect on the rate of transpiration. Is not one of the factors that affect rate of transpiration. It is not humidity, neither is it wind speed or light intensity or temperature. So this is not valid. So 1 and 2 is our option. Okay, what is the correct route for the movement of water from cell to cell in the apoplast? I just said it. Okay, pathway. I just said it a few minutes ago. From cell to cell, through cell wall. So what is it called? What is the movement? Just want to show you. I want to show you something, guys, just to remind you. I know you know this. Sorry, I'm just trying to scribble a cell, a tiny cell, plant cell. Okay, just to show you something, guys. So this is just a scribble tiny plant cell to show you something. So water moves. If water moves from cell wall, see, it's moving from cell to cell through the cell wall. That's apoplast. I can also move through the intercellular space if I have another cell here. Okay, and there's a cell wall. Pardon me. Okay, so water can move from the cell wall, enter the intercellular space here, and then moves here. Okay, so apoplast is through cell wall, through intercellular space. Symplast is from one cell to another through the plasmodious matter. This is symplast. That's through plasmodious matter. So through adjacent cell surface membrane, no, this may be vacuolar, through intercellular space, that's apoplast. Okay, apoplast can be cell wall to cell wall, or through intercellular space, through plasmodesma. No, this is symplast. C is symplast. Through Casparian tree, water can pass through Casparian tree. Okay, so the answer is bravo, B. Bravo. Let's go on. Which row shows the correct sequence for the movement of sucrose into the phlegm sieve tube? See, this question has come out like 4 times now. Oh, this it shows the answer immediately. Okay, remember the first one is loading. So the first one here, first diffusion of sucrose into the companion cell. That's not the first thing that happens. Sucrose has to move into the companion cell first, right? Co-transport of proton and sucrose. No, that's not the first thing. Proton has to be pumped out of companion cell first. And look at it. Active transport of protons into the companion cell. Into the companion cell cytoplasm. Active transport of protons into the companion cell. Active transport. Cytoplasm. Active transport of protons out. So it's not into, it's out. Do you get? So sucrose is transported out. Remember? Okay? Yes. So that eliminates this. Okay? And then we have co-transport of proton. Alright, and then we have diffusion. We have done this in the previous questions. Check them out. Okay? So this is the sequence, guys. Let's run. The electron micrograph shows a longitudinal section through a part of a plant stem, guys. Yeah, what is X? That's my question. What is X to you? Right? Pause the video and try it. If you check this, you can see this looks like sieve plate. It's a sieve plate, right? Yeah, sieve plate in the sense that it has sieve pores, and this therefore is sieve tube element. You can see. So after the sieve tube element, the next cell, this is a cell. The next cell, because this is an enclosed space, is a cell. The next cell is X. So is that xylem vessel element? No. Is that stem cell? No. Is it phlegm sieve tube element? No, because phlegm sieve is this one. So what is it? Companion cell. Companion cells are associated with phlegm sieve tube element because they help to load sucrose, okay, into it. So the answer is delta, guys. Let's go. Sodium chloride is added to a culture solution containing fresh water. Okay, containing fresh water single plant cells. What happens to the water potential of the culture solution when the sodium chloride is added? That may happen to the plant cell after 5 minutes. So if you add, this is it, okay. Now this is the cell, the plant cell is here, guys. You see, the plant cell is fine. Can you see? And then they now added solute. If you add solute, all right, sodium chloride is a solute. Water potential will decrease. That means water potential becomes more negative. So this says becomes less negative. It's not there. So we're going to focus on C and D because it becomes more negative. So that means that we have low water potential. So water is going to move out of this plant cell by osmosis from high water potential to low. So after some kind of 5 minutes, the cell experiences a distress. The cell is in dilemma. Something happens to this cell. The cell undergoes a process, okay, we call what? Plasmolysis. So the cell membrane start, right, withdrawing from the cell wall. So the cell does not become turgid because water is leaving the cell. The cell becomes plasmolized because, right, cell membrane is going to pull out. So yeah, because water is leaving the cell. So anytime water leaves plant cells, with time they become plasmolized. So C is the answer, guys. Which statement correctly describe transport pathways in dicotyledonous plants? Yeah, let's go. So we've talked about this severally. This question, this particular video is addressing the basic fundamental knowledge and understanding in this topic, right? And some applications. So it says, 1, pause the video and try it. In the apoplast pathway, water may move through plasmodious matter. No, apoplast is cell wall. You said it. In the simplest pathway, water may move through interstellar space. No. Interstellar space is by apoplas. Simplest is through plasmodest matter. So they switched it. This should be, see, watch this. Simplest is plasmodest matter. Okay. Apoplas is cell wall and intercellular space. Okay. Now the apoplas pathway may be blocked by Casparian strip. Yes. This happens in endodermis. Endodermis have suberin, which form Casparian strip. So 3 is the only correct answer, guys. Let's go. Which statement about movement of water from root to leaf is not correct? Not correct. Okay. Not correct. Okay. Pause the video. That means 3 of them are correct. 1 isn't correct. A continuous column of water is partly maintained by attraction of water molecules to cellulose. Yeah, this is correct. That's adhesion. B. Hydrogen bonding between water molecules enables mass flow. Yes, that's cohesion. Hydrostatic pressure in xylem vessel element is higher in roots than in leaves. Yes, this is correct because we have, right, what we call more water is in the leaf, in the root, sorry. So if this is xylem, okay, yeah, this is xylem in the root, so there's more water here. So the higher the water, the more the hydrostatic pressure. Okay, so that C is correct. Now this is water potential changes throughout the length of the xylem vessel. No, this is wrong. It doesn't change. Okay, keeps flowing. All right, that's D. Which terms describe the method by which water is transported with xylem vessel elements? Can see repeating the same thing. Xylem vessel elements. Which time? So this code transporter thing. Meanwhile, pause the video, guys. Let's see what I got. Okay, which times are used for the transport in xylem vessel element? Xylem vessel element. So, especially when it is moving along the xylem. Is that okay? So that's called cohesion tension theory. Transpiration pool. Water molecules stick to each other. See, forming a water column by hydrogen bond, and water molecules stick to the wall from hydrogen bond. So co-transport is not for xylem. Okay, it's for phlegm. This is it. Okay, that's not it. I think it should too only. What is the main function of companion cell in phlegm? Yeah, you should know this. Shout the answer to me. I can hear you. What do you say is the answer? Shout it out. Shout it, guys. Shout it, shout it, shout it. Oh, you're right. So, what is the main function of a companion cell? A says providing cytoplasmic contact. Yeah, you got it. Watch. So this is a part. Now this is phlegm. What is it called? Sieve tube element. And then the guy has a companion cell, which I call the companion, the wife, okay, the helper. The wife helps this guy to do his job. So the companion cell is the help of phlegm sieve tube element. Do you get? So can you see cytoplasmic contact through plasmodest matter? Yeah, so that sucrose can move here from here. So after it has loaded sucrose from source cell, this is source cell, maybe mesophyll, the guy loads sucrose here, sucrose finds its way there. Okay, meanwhile this is a tube. Okay, sorry. All right, now, okay, with sieve tube element for loading. See, A is correct. Providing cytoplasmic contact with the sieve tube element for loading. So this is correct. Now, providing structural support. It doesn't provide structural support. It's a sieve plate that does that. C, providing the nucleus for cell division. Nope. It has its own nucleus but degenerates after it is formed. Providing the source of assimilate. The source of assimilate for storage is not the source. Companion cell is not the source. Okay? Yeah, the source cells are the mesophyll cells where photosynthesis occurs. So A is the answer, right? So let's go. Some of the features present in transport tissues and plants are relisted. Look at it. We've done this before. So what is the answer? Which of these features are present in xylem vessel elements? Okay? Which of them? Xylem vessel elements. They should be lignified, no cytoplasm, no organelle. It has speed, yes, it has speed. not this, no plasmodium matter. Sieve plates are found only in flame sieve tube element. Okay, so it's 1, of course, no mitochondria, please. Right, 1 and 4. A diameter of a tree trunk usually decreases. See this same question, slightly during the day and increases slightly during the night. Which 3 environmental factors, if increased, could cause the largest decreases? So the ones that cause largest decreases are the ones that increases the rate of transpiration. We have done this before. Okay, humidity has indirect relationship, but I mean, solve this question for me. Okay, just solve it. All right, please solve it. So humidity, increase in humidity will cause a decrease in rate of transpiration. So anyway, so humidity, right, it can be the answer, because when you increase humidity, transpiration rate will decrease, and once transpiration rate decreases, the trunk will not decrease. So light intensity, temperature, and wind speed, they all increase the rate of transpiration, which then decreases the trunk. Increase in transpiration rate decreases the trunk of the tree. That is it. So any of the factors that increases rate of transpiration will decrease the trunk. So D is the answer. Sucrose moves within a flame sieve tube from a source to sink by mass flow. Which type of gradient within the flame sieve tube between the source and sink causes the flame sieve? Okay, causes the movement of sucrose. Yeah, which gradient moves sucrose? Okay, pause the video, tell me the gradient. What gradient moves sucrose by mass flow from here, sieve tube at the source, to sieve tube at the sink? It is not diffusion gradient, it is hydrostatic. Alright, gradient, pressure gradient, not concentration gradient. All this, so it is B. Alright, thank you guys for hanging out. Okay, so we're going to be doing another video for animal transport. Make sure you're getting ready for your exam. See you. Bye.